A session on how to move to the cloud and where to get started, and indeed guidance. This is more a freewheel session. So if you have any questions or any things that you would love to discuss during my talk, feel free. I am here, however, to show you things where you can get started, to guide you in the correct way on starting in Azure. And there's a little bit of a red wire inside of the talk I'm having. For those who don't know me, some overview about me. I'm Mike Martin. I'm from Belgium. So for those who do know me, I'm sorry. I'm Belgium. I'm sorry again. For those who don't know me, you will be sorry after this talk. I'm a solution architect for a company called Kronos, more specifically for the Crosspoint Solution Cluster, where I do mainly guidance of the internal companies and customers on their way to Azure. So this is a little bit the same thing that I will be doing with you guys. Starting off from certain kind of points in time, look at how you need to move. I'm also an Azure MVP, Azure advisor, well, the shebang, you can read it. Slight warning, if you want to follow me on Twitter, that's a big data stream for you guys. So people tend to say that I tweet too much. I think I'm mellowed now, only that guy can tell. But if you have any questions, but if you have any questions, anything related to architecture or the way you want to set up your environments, please feel free to drop me a line and I will be happy to reply you with whatever answers I can think of. Every case is specifically. Now, slight warning, this will contain some singing. So if you want to run, it's now the moment or not. So who knows this? Somewhere over the rainbow lies a cloud. Do I need to be feared now? No. The reason why I chose this as a red wire in my talk is because the reason when Dorothy was in Kansas, she was hit by a storm. Who has never seen The Wizard of Oz? It's a classic. You've all seen it? You think, okay. So remember what happened? So she started off in black and white, hence legacy. See the link? Yeah. Hence legacy, and all of a sudden she got sucked up by a twister over the rainbow into the clouds. There's your start of your journey. The thing is, she wants to get back to her legacy, but she wants to get back to what she knows. And all of a sudden she said, I don't think we're in Kansas anymore, Toto. It's the part where she meets all the munchkins. Follow the yellow blick lot. Follow the that's Korean. Sorry, that's not funny. And that's the entire goal of this thing. You wanna make sure that your applications that you know and that you need to maintain and that you wanna actually move to the cloud or start writing off new applications into the cloud. You wanna make sure that it's something that you know and that you can get hold of, and that it is something that, how should I put it, that grows with you. This is a little bit what this talk is about. Now, this morning, my good friend over there, and this is a very slow site, I don't know why, but for me that loads always very, very slowly. Yeah, maybe I should. This morning, my good friend over there also showed this slide, and I think some others might have shown this. But if you today look at the ecosystem that you have at hand when designing applications, there's a plethora of choices. Yeah? But it all comes down to the same three things, and these are the things that I will show you here. We can either move natively to the cloud, we can either migrate to the cloud, or we can go in a hybrid way and make sure that we can design our applications like that. And then go that extra mile. Yeah. So who has never seen this slide before? If you did? You never did? Oh my God! And it even has wrong information because this should be 40 and actually it's 42. And there's still BizTalk services. So I grabbed it from the wrong dick. I have a couple of these and some stale dicks, and you know but still indeed BizTalk, and even the old Logic Apps logo. So and it should be Cosmos DB instead of Document DB. And most of the time people go, I'm so confused now because there's too many things on there. All right. So when Dorothy hit Oz, the good witch of the, I think it was the south, came up to her and said, well, if you want to go back home, you should visit the Wizard of Oz, hence what the movie is about. And she said, you need to follow the yellow brick road. So this is the tumbling road I'm gonna take you. And along that road, she gets acquainted by 3 guys. And actually, those guys she actually knows, because they are the same guys she knew from Kansas. I don't know their names anymore, but they started off by ending up being the Scarecrow, the Lion, and the Tin Man. And they all had specific needs. Remember that? Right. So the first one I'm going to talk to you about is If I Only Had a Heart. The Tin Man wanted a heart. Or in this case, if you want to start off in the cloud, the first thing that most people or most customers or most companies think of is lift and shift, infrastructure as a service. And that's indeed the easiest starting point. But how do you start designing them, and how do you get there? Well, most of the time you start off by redesigning your network and start making it hybrid. And making it shift and lift, it can give you a lot of services that you want to use. Let's say you want to move to the cloud. Well, how are you going to do that? Are you going to move all your workloads to the cloud? Are you going to move your production, your test, and your acceptation environments also to the cloud? And this is just a sample design of what can eventually end up into the cloud. Now, where do you start? Well, first of all, you see, are we going to go full cloud? Or just going to keep a couple of servers back on our on-premise? Well, then we need to design and think of an infrastructure where we can have a high bandwidth communication channel towards Azure or any other cloud. Actually, this can also apply to any other cloud vendor. That's not probably the word they want to hear from Microsoft, but that's basically it. These principles stay the same. So you need to make sure that you have a good connection, because if you want to move your machine, your workloads to the cloud, you can either start up by creating things from scratch and just copy your applications over, or you can just pick up your VMs either by tooling like Azure Site Recovery. Who hasn't heard about that one? Okay. So Azure Site Recovery is actually not used for that specific reason, or not designed for that specific reason, but actually you can use it for that reason. Because Azure Site Recovery is more on failing regions and replication of your data center to a disaster recovery data center. That's a tool that you can use and abuse in that direction. Another thing that you can do is use just stale new VMs, copy everything over from the internal side. Yeah. Azure Site Recovery, we had that. And what that does is it just picks up the machines, make sure that they're all replicated through storage, and your devices will show up. There's some pitfalls there. Well, because first of all, you need to redesign your network boundaries. Your IP addresses will change. Can you live with that? Have you ever designed your network topology or your application infrastructure not on IP but on DNS? Are your servers capable of changing your IP? Because some servers cannot change their IP, or it's hard to do, like SQL servers, for instance. So these mechanisms will help you, but you need to keep into account that it's not although it seems a very straightforward process, it's not. Yeah? And then you start off by, we moved our servers to this new environment, and we have them there, but is it satisfying enough? Is this what we want? I mean, infrastructure as a service is nice, and most of the components that you saw on the first slide reside on infrastructure as a service. All are serverless, for those who are in the previous session here. That guy talked about function. It's just worker roles which are being deployed on VMs, which are again infrastructure, and somebody needs to manage them, but it's not you. It's other people, right? It's Microsoft. But it's still infrastructure. Yeah? So question is this the total VM package that you get at the end? Is this what you want to go for? Because you still now have something extra. You don't only need to manage your infrastructure, you also need to manage that Azure infrastructure too. You need to go to the portal and monitor your Azure services, and you need to monitor your internals of your application and your application service, because you need to do the patch management. You need to do all the security patching. You need to do all the nifting and tifting in IP ranges and all these little things, just like you used to do in the past. That could sound wrong, but for most people, they have it in a happy place and say, hey, now we're cloud, we have everything we need. And that's not most of the time where you want to go, because there's some other downsides besides the management factor. You also have that extra cost. If you don't scale well enough unless you start designing your infrastructure as a service to a scalable environment. But then again, is your application ready for that? Can your application scale? I see many customers today still writing stateful, session-full applications. They don't scale that well. So that's also something which we will talk on in the end, where can we find that thin line? But then again, you're already in the cloud. So it's not all that bad, because you can now start using easier ways to get to services that are available at hand. Right? Am I boring you guys so far, or is it interesting? Right. It's pretty much all talking that I'm going to do. I always do a lot of talking, he can tell. But in the end, it's to make sure that you understand where you're going, and I will show you some demos which can help you to start off easy with your application movement, but it's really about the thinking process and about the way you need to design your applications or your next landscape. Yeah. So it's not a pretty solution, but it's a start. That's usually your first start. It's that theorem that you have. Upside is you have full control over your environment. Yeah. But ask yourself or ask your IT organization, are you up for that full control where you can actually benefit more features and less stress if you go other directions? That's a question you should ask yourself. Right. This is what I usually do in companies when people come to me and they say, we want to go to the cloud, and we go into brainstorming sessions and we just go workshopping. They say, we have this architecture, how can we move that? And they always think we have one solution. Every landscape is different. And that's, once you get all the principles, you can actually start moving bits. So, the second friend that Dorothy had when we followed the yellow brick road again was, if I only had a brain, the scarecrow. He was always thinking that he was not very smart. This is where your friend PaaS comes in. PaaS is what we say most of the time being used in a startup mentality. If you have a new corporation, if you have a new company, and you see that a lot. I don't know if you guys see that a lot, but if you have newcomers creating a new organization, they will always start looking at PaaS and SaaS services. Why? They don't want to manage all the things that we saw in the previous few slides. They don't want to go VMs unless they cannot do it differently. Because some workloads that you have will not run on anything else. I mean, like for instance, I'm at a customer right now, and they want to run a Sitecore environment in Azure. You can run a Sitecore environment in Azure, and there's either way that you can do it. You can do it in traditional infrastructure as a service. You can also do it in a PaaS service, because there is an AZ environment package that you can deploy to AZs, and that can run in a scalable way. But for some components, you still need infrastructure as a service, because that vendor specifically doesn't have compliant components that can work together with Azure services. They have this thing called, I think it's called an experience database, and that's based on MongoDB. Now, Mongo is a NoSQL environment. It's very document based, and it's very fast, but it doesn't exist as a native component in Azure. We have Cosmos, which has a Mongo related API, but that doesn't do the trick for them, maybe in the next iteration. And that's also something that you need to take into account when you're doing movement to the cloud. Are your vendors up for, are yourself up for a renewal of your licensing? Are yourself up for a renewal of your application landscape? Do you want to go for that new version? Because you're already going to the cloud. That's a double impact that you have there. And people don't think about that. So startup mentality is something that, oh yeah, we don't want all that. We don't have any legacy. We don't want to do legacy. So we just go past your services. We just create websites, move them into ASEs or app service plans or whatever you want. Yeah? And just link them to Azure SQL databases or even Cosmo databases and mash them up like that. And see their environment not really as a development environment, more as a mashup environment. Yeah? But we do need to take into account some things, because PaaS doesn't automatically mean that you get all these things. One of the false assumptions that most people have when they move to PaaS is that they don't need to design for failure anymore. Your service still needs to be designed on a failure level. And what I mean is, you don't talk about disaster recovery here. There's a big difference there. If you talk about disaster recovery, that's backup, RTO, RPO, and all that shizzle. You want to be restored in a couple of hours and you want to be back up and running. But designing for failure means that you will do everything in your powers to make sure that your service will stay up and running 24/7. Azure has that kind of capabilities on their service level, but it doesn't automatically mean that your website or your VM or your other service will automatically be resilient enough to guarantee your own service as a 24/7 service. Am I making myself clear here, or am I talking? No, no. I want some interaction from you guys. It's some people still think that, wait, so I'm running a service in Azure. It has data centers all over the world, and you're telling me that Azure is not fail-safe? Yes, it is. But not for your service. Not for your own stuff, but for their own services. I don't know how you explain it, but people always go like, wait, that's not what the sales guy told me. Hence why you're talking to me, not to the sales guy. Hence, the best example here to give is Azure Storage. It replicates, but you're not in control. And you cannot touch the replicated data, but it replicates for itself for the service. For instance, let's say you have VMs running on a classical way, and not classic VMs, but running on non-managed disks. What will happen is that your disks will stay available to your machine, even if there's a service disruption. But does that mean that your machines will automatically fill over to a new region? No. You need to foresee that yourself, because the service that you're providing, that's something else. There's a great talk on designing fail-safe services by Martin Baljau from the past. He gives a talk at 6 or something, 6:30. It's doing a rider thing, but he runs his own SaaS, which is also a managed service that you can take, MyGit, and they have a good idea on how to have fail-safe, because it's not only running the services here, but make sure that you have a hot standby or cold standby or a really regenerated standby on the fly. And you can use services like Traffic Manager to fail over your service completely. Or you can have VM scale sets, make them move up and make sure that they are well scaled over your own subscription, and make sure that they pass through like that. It's that easy, but you just need to keep into account that you're not yourself fail-safe. That's one of the flaws in communication from a vendor perspective. And I always need to explain that again to customers every single day. I told you it was really talking. So if I'm boring you, you're free to go. But if you find it interesting, who's happy so far? Yeah? Okay. Good. Until now, you cannot foresee the future. No pressure. No, there's no pressure. Cool. The second thing that you need to take into account is if you're doing positive services, even from a hybrid point of view, you need to decompose and make sure that every single piece of your environment scales or is fail-safe resilient itself. We've seen enough of monolithic applications, more than enough. Yeah, I mean, we all came from, or yeah, I'm that old. We all came from the time frame where mainframes were rulers of the world. Dino time, I know, Jurassic Park in the basement, some dudes switching magnetic tapes and things like that. But from that point of view, we've been creating monolithic applications all over the time. And then we had this real distributed way of thinking, client-server. Still monolith. Because what would we do? We need a web server, we need a database, let's put it on the same machine. But they're two different things, but they're still monolithic. And then we went from, maybe we can start thinking them apart and have layers. Not really monolithic, but still. Yeah. So try to decompose and make sure that every single piece that you use can scale on its own. Now, most Azure services can have an automatic scaling for that and have a fail-safe mechanism that you can use or abuse or just configure or whatever you have. Let's say, for instance, you want to design an application that can handle your invoicing. You can do that with logic apps, for instance. Just give your example. Just give me ideas. You're my muse for the night, for the day. But also, what if you're designing a system that needs to go back and forth, and you need to make sure that everything that you do doesn't get stored in a database because that's too slow. No, just put it in message queues. If you get a little bit more bang for buck, put it in service bus. But at least that part will stay vibrant and alive while your front end dies or your back end dies. Service bus has this great capability that from the moment that the messages aren't picked up, it will readdress them to the sender, or you can just pick them up whenever you want to. You can archive them. There's all these capabilities that you have, but people do not think about those. Most of the other organizations that I know are still too traditional in thinking, even when it comes down to new technologies. So decompose, that means that if you have issues on your front end, your front end should be able to scale or to fail over. If you have issues on your middleware, that should be able to scale on itself. Database, same thing. SQL databases, for instance, they can scale massively. They are elastic. You can have pools that can be foreseen. If you if you can calculate your workload enough on your database, if you have no clue whatsoever how many load that you have on your database, and that's also something which is very hard, just take a scale which you think is reasonable and go from there. Afterwards, you can still scale out or scale up. Yeah? That's the decomposition thinking. Sorry? Depends on the service. Yeah. Yeah. Okay. So you can do some DTU calculations on those and maybe foresee a larger instance, but the elastic database scale will be easier there. You can easily provide a pool for that, and then that will be picked up by the pool. Yeah. But for you guys, it's interrupted workloads, and you can predict. It's a predictable burst. So you can actually either do that automatically or just have the resources. Right? Yeah. Scale it down again. And actually, you can do that for any. Yeah. Yeah. And exactly. But you can, for every single service that you have, you can auto scale or degrade if you want to. And scaling goes two ways. I mean, you get upscaling and outscaling. Either you make your machines larger, but then you need to make sure that you still have taking into account the failures. Because if you do upscaling, that will mean that your service will go down if you didn't foresee resiliency already on that level. Availability seed, VMMS, whatever. They need to have the concept of update and fault domains at that point in time. For those who don't know what update and fault domains are, raise your hands. Everybody knows it? Ah, okay. So fault domains are two different racks. Update domains are two different blades. And that means that if you design or look at a service perspective, service A and service A will run on both racks. Service B and service B will run on both racks. Service A will be updated, and then this one will be updated, and vice versa. And not on the same time. If one fails, the other one will take over. And they will be taken into account. And by default, some services have 5 and 3 update domains and fault domains. Others have 5 and 7. There's different scenarios there. But learn your limits to those services too. That also come into place with service dependencies, because there's limits, there's capabilities that you have. So you know that every single subscription that you have has limits. You can, for instance, only create 200 storage accounts. Actually, you can create more. Just a call to Microsoft saying, we need more storage accounts. And then they open up. Now they can. In the past, you only had like 100. And that's it. If you needed more storage accounts, you needed a subscription. You could, for instance, cloud services, you can only create like 40 cloud services with 50 VMs, things like that, because of the limits of throttling of storage and so on and so on. So you need to take into account service dependencies. And if also from your own perspective, if you need to do service dependencies, make sure that they are always available. Again, taking into account 1 and 2. Failure, but from a DR perspective, that's also something you need to foresee. Could be well that you foresaw resiliency all over the world, but still foresee that you need to restore an oopsie moment. Because it doesn't always mean that you have a failure that your service is down. It could also be that on a Monday morning, you have a minion running around in your organization updating all SQL databases, but they forgot the where clause, and they update the entire table instead of just that single instance. It happened to me. I mean, Monday morning, no coffee, and all of a sudden, all municipalities. I'm talking about a long time ago. All municipalities in Belgium had the same postal code, same zip code, all 2000. Go figure. I know Antwerp is the center of the world, but I don't need to exaggerate on that. So, you get it. But you need to take that also into account. You need to make sure that you have disaster recovery next to your failure. Design for failure. And that could be backups. It could be also just a hot standby, just to compare things. But that could also be A/B testing in web apps, for instance, with staging slots, and just swap them. That's also disaster recovery in that matter, because you can easily go back to a previous state without redeploying and, again, risking failure on your side. Okay? Scaling. I mentioned scaling a lot already. Try to automate it as much as possible, even if it doesn't come out of the box. There's a lot of capabilities today, either from Azure or from a third party that can scale for you. Third party, for instance, is CloudMonix. CloudMonix, they have a service inside of CloudMonix that can auto-scale for you based on certain thresholds. Now, scaling is the hardest part in an Azure environment, especially if you're doing web apps in an ASE, for instance, or VMMS, because you never know how well the throttling will handle. Let's take, for instance, I need to scale my VM from the moment it goes over the 50%. That can easily go every 10 seconds. You want to scale every 10 seconds? Because you need to descale again. You need to scale down again. Yeah? That's also something that you need to take into account. Idempotency, or what's it called again? Idempotency. Idempotency, that's the thing. I misspelled it there, sorry. Make sure that you can recreate as much as possible. Again, for previous reasons. And this is just common sense that you need to do. But this is something which we weren't doing in the past, or at least not ourselves. Some things did that itself. Mainframes, for instance, they could all do that on the fly. Not saying that I'm a hardware lover here, but you get the idea. And last but not least, but also keep into account that you're not only are doing one single area, but you also have the capability of doing geo-distribution. Use that capability. Again, for all the previous reasons. These are design principles that you need to follow, and the things that they actually don't teach you at school, but you should know them. Yeah? And that will result in speed, scale, and economics in the end. Because from a business perspective, if everything stays up and running and you do your scaling correctly, you will pay peanuts. I literally have seen services where if you do scaling the right way, you can actually gain more than just by running 2 large instances of a certain VM or by 2 large databases, for instance. In the past, it was easier when we had Azure and we had only cloud services, and God, I miss those that they are not as a armed environment. But the beauty about cloud service was that you could scale up and out, but 10 extra small services could run the same workload that a large instance could not run. Why? Because of the distribution and of the capabilities of the statelessness of the service that you were writing. That was the beauty for it. And you would pay like peanuts. Yeah? If you did that same thing in 2 larger instances, well, it would cost you more. It would get the performance, but maybe not the same because of the non-distribution factor. Okay. Scaling again and speed, that speaks for itself. So where to start? Well, start off light. If you're gonna go PaaS, try to think in decoupling and even just pick up that application which is running there and move that first and see if it can still connect, and then think hybrid too, because maybe you just want to keep your backend there. Move it there. Start off light and if you're doing new developments, also start off light. Try not to over-complexize things. Unless you're doing IoT or something, you need more components. But start off with a single component and add things gradually. It's just a little bit like drinking Coca-Cola. You start off with water, then you start off with light, and then you start with zero, and then with light. Yeah? And then you add some more sugar or syrup, and before you know it, you're hypered. You get the idea. Now, luckily, when doing Azure, you have some references which you can take a look at. It's the availability page and the patterns page. It's always a good part to start looking at it. But why? Because they give you guidance on each specific service or each specific scenario. And these go a long way. I mean, the patterns books, for those who, you get the slides eventually, it's easier clickable. If you can take a photo, but you get the slides eventually. So. Yeah, there is, and I think it's even available through the patterns site. There used to be a patterns and practices group, which is still there, and those were the guys that invented the enterprise the enterprise building blocks, if I'm not mistaken. And one of these blocks you still need today if you're doing like SQL connectivity. Again, talking about failure, SQL has this nice feature out of the box built in when you're doing development to SQL database in your .NET environment, and the entity framework has that, I think, is if you design your SQL database to do geo-replication failover in read-only configuration, they fail over to a secondary site, actually you can have a switch in your code saying if it fails, automatically go and look at the secondary location, or the secondary locations, as you can have many. Yeah. This is just one of the examples that you can actually implement. It's very easy. Just look at geo-replicated environment. I was going to say something else. And this is actually an implementation of one of these patterns that we had, because there was this one thing in the enterprise building blocks called the transition fault block, which I would actually look for a secondary environment, and there was a pattern that was so anti-pattern that it was implemented that way. So every single time you would write an application, it would also look for the fault environment, and it will fail over itself. So that way you didn't have to do that much work. They implemented these things in some of the services that are running today too. Service Bus, for instance, also implements that. Okay. And then you can no longer see VMs, but you see PaaS services all over the place. And you still might need some VMs, like I mentioned, the MongoDB thing, or the monitoring and service bus for your disruption here, where you can have your messages back to, and there's a link missing, and that can all run in a secure way, because that's also something which is lightly forgotten, that security. And sometimes you need that extra grinder thing, and you want services only to be available on the inside. Today you can. Azure now has the capability to connect your infrastructure to the virtual infrastructure in Azure, and even these Azure services, so not VMs, but Azure services can be integrated tightly into your VNet, just like they were running on your own data center, without having you to manage everything, just a connection point. That can be endpoints, or that can just be service integration directly onto the VNet. There's a big difference there, because the endpoints is just the exposure to an IP on the inside, where the integration on the VNet is actually an addressable immediately. Best example there is the storage. They have an endpoint, and it's just into the portal, or with PowerShell, you just flip a switch saying integrate it into my VNet, you select the subnet, and then you can secure all the access to that storage account through NSGs with a service principal, which is a better design than everybody going outside back to the loop, to the internet, if you don't want a secure connection. You never know whatever reasons that you want to do that. Same thing goes for SQL database. You can now have managed instances integrated into your VNet immediately. So Microsoft runs it as a service, full 100% compliant with what we have on-prem, but you don't have to worry about the SQL Server environment, only about the databases. Index tuning is still something that you need to foresee, because that's still something on the positive side that you need to foresee. But, or service endpoint exposure and just have a normal non-managed instance and do it like that. That's also a way. And in the end, when Dorothy, Tin Man, and Scarecrow get to the wizard, you will actually see that when Toto pulls away the curtain, it's not a wizard, it's just a man who gets exposed. Why I'm showing this is because the services that you're addressing still stay the same services as you know on-prem. Web apps is just IIS or Tomcat, and you have some granular control over that. For instance, web apps, you can actually change some IIS settings, but a lot of people don't do that or know that. You can have integrated configuration settings inside of the portal, or you can do some management on the Kudu side. Again, that's one of those hidden gems. Kudu is a console that you have from within either the portal, or just go by your Azure website.scm.azurewebsites.net, and you get there and you get just a portal with a console on either in command line or in PowerShell, but you also have some information on your environment. You see all the environment variables of your IIS, and you can change those if you want to. Not on the server level, but on the application level. Yeah? So they still stay the same. SQL Server is still the same. The only thing that you don't have with SQL database is CLR compatibility, but you don't want that anyway. If you're doing that, you're doing it wrong. Yes, you have that actually in managed instance now, but anyway. So we only had one character left now, and I'm almost done. Migrations to PaaS from EOS, because remember the first story I was telling you? You had infrastructure as a service, and you want to step away from that. Gradually start looking at which services we can now move away. That could be, we have a SQL server, But hey, it's just a standard database. We don't do anything funky there. We don't use a CLR. We don't have any services running on our SQL server integrated immediately. We don't need SSIS, although you can use that now in the cloud. Data Factory is a full SSIS implementation. But yeah, let's just take that away and see how that goes. Step 1. Step 2. Oh, okay, that website. That's a little bit harder. It's legacy. How can we take a look at that? Well, there's some tooling for that. This is an older tool, but it still works. For those who've never seen that, have you ever seen the website migration tooling? Yeah. It's okay. It's a small tool, and it's just a web page actually showing, and it can actually look for your environment of SQL servers and websites that are connected to each other, and will generate actually a pass service for you. And it's very easy to use. I'm running a local website here, and what you can do is just click continue. It will generate, it will look at the IIS things that you have, all the dependencies that it has. Just press next. It will generate a readiness report, and you can see that there's some schema errors, but I don't care. It's ASP.NET Core, I don't care, because it's a .NET application. It's not an ASP.NET application. You can see all the settings here. It's bound to compatibility settings. It has a custom hostname. Just do an upload, and then Azure will generate for you a migration assistant saying what you can do with it. As you can see, well, it's okay. The full assessment has been completed for migration readiness. Well, you're good. Begin your migration. And then you have all these capabilities saying, okay, this will be guided. We will begin a migration. We will log into our Azure environment. We wait a while. Or am I seeing things that aren't there? Because sometimes it could happen that, let's see, where's my mouse? Sometimes it could happen that there's a window hidden somewhere. Now, anywhere. And it will actually ask you in this subscription that you have, which subscription do you want to pick, where do you want to deploy, and start your migration. And then you just start creating by your, it just asks you to start creating your assets. So let's do that. Let's go for North Europe or West Europe. That's even better because that's Amsterdam. Where are we? Here we are. Start the migration. What? We want this site to be created, and here we go. It will ask me for all the capabilities that we have. Now, this is just one of the examples that can help you to look at your applications, whether they're compatible to be running in this day. I don't say that you have to migrate them like that, but just use them as a POC. Or just even create a site or create a database, deploy your backpack, DACpack, or whatever you have. Deploy your web deployment package or just a zip file and just move it into Kudu and make it unzip there, and that will also work, and see how it goes. It's just a matter of starting light. Don't start with a production site and move it immediately to Azure, but just test it first, and you'll see where you get. There's other toolings that can do that too. There's the assessment for VMs, for instance. These are all free tools that Microsoft provides. It starts running. Yeah, that's the downside. It all goes to the other screen. As you can see, there's yeah. What would you like to assess? Well, Active Directory. I need to move it to the cloud. Should I go cloud only? Or should I stay with the DC and deploy it into a VNet and integrate it like that, and then do ADFS, create a proxy, move it outside, do AAD connect and do the connection like that. All things that you can think of, depending on the scenario that you want. There's another one. This the readiness assessment, but there's also the here we are, the optimization assessment for the same SKUs. Actually, underneath it gives you a different reporting, and you can see whether you actually can optimize to a PaaS service or rather a VM. Yeah. These are just a few tips and tricks that I'm giving away here, but these are the things that can actually help you. And the only goal that you need here is to get to us. We're off to see the wizard. Right. So, on that bombshell, 45 minutes are up. I hope you enjoyed it. I hope you learned at least something, or just gave you some ideas where you can think of and go from there. And I would say have a nice remainder of the evening, and I hope to see you maybe tomorrow morning for my open source talk on Azure, which is just a level 100. All right. Thank you for your attention.